In the next two lessons, we're going to talk about polarity. So first, just a quick review of covalent compounds. Things that we should know about covalent compounds are sometimes called molecular compounds. Covalent or molecular compounds are formed between groups of nonmetals. So an ionic compound is a metal and a nonmetal. Covalent compounds are going to be nonmetals. We know that atoms still follow the octet rule, but they do it a little differently. Atoms follow the octet rule by sharing valence electrons. So let's say I had HCN. So hydrogen has one valence electron. Carbon is in group 4. It has 4 valence electrons. Nitrogen is in group 5. It has 5 valence electrons. So what's going to happen is hydrogen can share one of its electrons with carbon. So hydrogen now has 2 valence electrons, one of its own and the one that it shares from carbon. Carbon and nitrogen now each have 3 unpaired electrons. They can share 1, 2, 3 pairs of electrons. So carbon now has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. 4 of its own, 1 shared from hydrogen, 3 shared from nitrogen. Same thing with nitrogen. It has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So by sharing valence electrons, each atom completes its octet. Hydrogen has 2 electrons, which means it has its full s orbital, so everything is happy. There are 2 different types of covalent compounds, and the difference is going to depend on something called electronegativity. Electronegativity is the tendency of an atom to attract electrons. Tendency of an atom to attract electrons. We can have compounds that are polar covalent. If a compound is polar covalent, it means that the electrons are not shared equally. So the reason that they are not shared equally is due to a difference in electronegativity. What's going to happen is the more electronegative atom pulls the shared electrons closer and creates what we call a partial negative charge. So that means if one atom is pulling the electrons closer, those electrons are being pulled away from the other atom. So electrons get pulled away from the less electronegative atom. Since electrons are negative, if those negative charges are getting pulled away, it's going to become more positive. It creates a partial positive charge. A good example of a molecule, a covalent molecule that is polar covalent, is going to be water. So we can look up the electronegativity values of hydrogen and oxygen. Hydrogen 2.10, oxygen 3.44. So I can draw a Lewis structure for water. It is bent. And what happens is we can see that oxygen is more electronegative. So these electrons are going to be shared, but what's going to happen is those electrons are going to be pulled closer to oxygen. Since electrons are negative and those shared electrons are pulled closer to oxygen, oxygen would get a partial negative. The reason we say that it's a partial negative because it's not actually gaining the electrons. It's not gaining an electron and becoming an anion. The electrons are still shared, so it's not like a full negative, like it's gaining electrons. Those shared electrons are just pulled closer to it. Since those shared electrons are being pulled away from hydrogen, hydrogen would get the partial positive. This is a polar compound, or it forms what we call a dipole. That prefix di meaning two because it has two poles. I have this negative pole up here and my positive pole down here. So the first type of covalent compound is called a polar covalent compound. We could also have non-polar covalent compounds. If a compound is non-polar, the electrons are shared equally due to similar electronegativity values. An example of a nonpolar covalent compound, diatomic fluorine. So each fluorine has one unpaired electron and they're going to be shared and they're going to form a single bond. Well, each of these fluorines are going to have the same electronegativity value. Think of electronegativity kind of like we're playing tug of war. So going back up to water, oxygen is more electronegative. It has a stronger pull on those electrons. Imagine you're playing tug of war with someone who's stronger than you. they're going to pull that rope closer to them. Now you're playing tug of war with someone who is equal in strength. You're both pulling on that rope. Well, is that rope really going to pull one way or another? Not really. It's probably going to stay right in the middle. Both of these fluorines are attracting the electrons with the same magnitude. That means they are going to stay right in the middle and they're going to be shared equally. A question that students always get is, why do we say that it's polar if they're not shared? Because doesn't non mean not? So it doesn't come down to that. Non-polar means there is not different poles. I don't have a positive pole and a negative pole, so it is not polar. A polar covalent compound does have multiple poles. It has a positive pole, it has a negative pole, so that is considered polar. So make sure you understand the difference between a polar and a non-polar compound. For the rest of the lesson today, we're going to talk a little bit more about polarity. Polarity is the separation of charge due to the unequal sharing of electrons. Separation of charge due to the unequal sharing of electrons. So we just saw that when we looked at water. We had a separation of charge due to the unequal sharing of electrons. When we have that unequal sharing of electrons, it results in a partial positive pole and a partial negative pole. This creates a dipole. Prefix di meaning two. So we form a dipole when we have two different poles. So what we are focusing on today is going to be called bond polarity. There is also overall or molecular polarity, and we'll get to that next lesson. Bond polarity is the easier one. Bond polarity depends on the difference in electronegativity values. Let's say you were asked to predict the bond polarity for, first one, the bond between hydrogen and chlorine. So what we want to do is look up these two atoms on our table of electronegativity values. Chlorine is 3.16. Hydrogen, 2.10. We always want to do the bigger number minus the smaller number. So chlorine is 3.16. Hydrogen is 2.10. So my difference is 1.06. The bigger the difference in electronegativity, the more polar the bond is going to be. On this same reference sheet down at the bottom, we have a nice table to help us out. My difference was 1.06, which falls in this range. this is going to be a polar covalent bond. So what happens when hydrogen is bonded to chlorine, chlorine is much more electronegative. So what's going to happen, since it's more electronegative, it has a greater tendency to attract electrons. So chlorine is going to pull these shared electrons closer to it. If it's pulling those shared electrons closer to it, chlorine would get the partial negative, and hydrogen would get a partial positive. Those electrons are being pulled away from hydrogen, which induces a partial positive charge. Let's try one more. What if we had a bond between two chlorine atoms? Well, chlorine is 3.16. We want to take the difference. My difference is 0. So you can probably predict what type of bond it's going to be, but going back to our chart, if I have no difference in electronegativity, this represents a non-polar covalent bond. That means the electrons are going to be shared equally. When we have a non-polar bond, we don't have to draw any poles because it is non-polar. It is not polar. A represents a dipole. I have two poles. I have a negative pole and a positive pole. In B, the electrons are shared equally, so it is not polar.